Engines are the invisible force behind modern life. From the moment you wake up to the time you sleep, engines power your world. They move cars, generate electricity, fly planes, and even run factories. But not all engines are the same. Each type works differently, built for a specific purpose. Understanding them gives you a clear picture of how machines truly function. Let's start with the most common one, the internal combustion engine. This is the engine inside most cars and motorcycles. It works by burning fuel inside a chamber. Fuel mixes with air, gets compressed, and then ignites. This explosion pushes a piston, creating motion. That motion turns the wheels. There are two main types here, petrol engines and diesel engines. Petrol engines use spark plugs to ignite fuel, while diesel engines rely on high compression. Diesel engines are usually more efficient and powerful, which is why trucks and heavy vehicles use them. Next is the external combustion engine. Unlike internal combustion, the fuel burns outside the engine. A classic example is the steam engine. Water is heated to create steam, and that steam pressure moves pistons or turbines. Steam engines played a huge role during the Industrial Revolution. Today, they are less common in vehicles, but still used in power plants to generate electricity. Now move to electric engines, also called electric motors. These are becoming more popular every year. Instead of fuel, they use electricity stored in batteries. When electricity flows through the motor, it creates a magnetic field that causes movement. Electric engines are clean, quiet, and efficient. There's no combustion, no smoke, and fewer moving parts. That means less maintenance. Electric cars are growing fast because of this advantage. Hybrid engines combine both internal combustion and electric systems. They are designed to use fuel and electricity together. At low speeds, the electric motor runs the vehicle. At higher speeds, the fuel engine takes over. This reduces fuel consumption and emissions. Hybrid systems are a smart transition between traditional engines and fully electric vehicles. Another important type is the jet engine. These engines power airplanes. Instead of pistons, jet engines use air compression and high-speed exhaust. Air enters the engine, gets compressed, mixed with fuel, and ignited. The hot gases shoot out the back at high speed, pushing the plane forward. This is based on Newton's third law. Every action has an equal and opposite reaction. Jet engines are extremely powerful and designed for high-speed travel. A variation of jet engines is the turbofan engine. This is commonly used in commercial airplanes. It has a large fan at the front that pulls in air. Some air goes through the core for combustion, while the rest bypasses the engine, creating additional thrust. This makes turbofan engines more efficient and quieter compared to basic jet engines. Then, there's the rocket engine. This is used in space travel. Unlike jet engines, rockets don't need air from the atmosphere. They carry their own fuel and oxidizer. When ignited, the reaction produces massive thrust, allowing rockets to escape Earth's gravity. Rocket engines are extremely powerful and operate in extreme conditions, including vacuum. Now, consider rotary engines, also known as Wankel engines. Instead of pistons, they use a rotating triangular rotor. As the rotor spins, it completes the intake, compression, combustion, and exhaust processes. These engines are compact and smooth, but less fuel efficient. They are rare, but have been used in some sports cars. Another category is the gas turbine engine. This engine is widely used in power plants and some aircraft. It works by compressing air, mixing it with fuel, and igniting it. The expanding gases spin a turbine, which generates power. Gas turbines are known for their high efficiency at constant speeds. Stirling engines are different from most engines. They use temperature differences to generate motion. Heat is applied to one side, and cooling happens on the other. This creates pressure changes that move pistons. Stirling engines are quiet and efficient, but they are not widely used in everyday vehicles due to complexity and cost. Hydraulic engines use fluid pressure to generate motion. These are commonly found in heavy machinery, like excavators and cranes. Instead of fuel combustion, they rely on pressurized liquid to create force. They are powerful and precise, ideal for lifting heavy loads. Pneumatic engines work similarly, but use compressed air instead of liquid. These engines are used in tools and some experimental vehicles. They are simple and safe, but not very efficient for large-scale applications. Two-stroke and four-stroke engines are classifications within internal combustion engines. A two-stroke engine completes a power cycle in two movements of the piston, making it lighter and simpler. It is commonly used in small machines, like chainsaws and scooters. A four-stroke engine takes four movements: intake, compression, combustion, and exhaust. It is more efficient and widely used in cars. Engines can also be classified based on their layout. Inline engines have cylinders in a straight line. V engines have cylinders arranged in a V shape, allowing more power in a compact space. Boxer engines have horizontally opposed cylinders, offering better balance and stability. Modern technology is pushing engine innovation even further. Hydrogen engines are being developed as a clean alternative. These engines burn hydrogen instead of traditional fuel, producing water vapor as the main emission. There are also fuel cell systems that generate electricity using hydrogen, combining clean energy with efficiency. Each type of engine has its strengths and limitations. Some are built for power, others for efficiency, and some for sustainability. The choice depends on the application. Cars need a balance of performance and efficiency. Airplanes need extreme power and reliability. Industrial machines need durability and strength. Engines are constantly evolving. As technology improves, newer designs aim to reduce pollution, increase efficiency, and deliver better performance. The future may be dominated by electric and hydrogen systems, but traditional engines still play a major role today. Understanding engines is not just about machines. It's about understanding how energy is converted into motion. It's about seeing how innovation shapes the world. Every engine, no matter the type, follows one simple idea: convert energy into useful work. And that idea continues to drive human progress forward.